Now that we are done with the concept of demand and supply, we are well set to talk about elasticity. The first elasticity that we do is what we call price elasticity of demand. So before I delve into, what is price elasticity of demand, I would like to talk about elasticity in general. So what is elasticity? Well, in economics, we say elasticity is the responsiveness of one economic variable, for example, variable X, to a change in another economic variable, for example, variable y. So, for example, if x is changing, how will that, for example, affect y? Or if y is changing, how will that affect x? Will be what we call elasticity. For example, if I say x is going up by 10%, right? But y is going up by, as a result of change in x, by, for example, more than 10%, let's say 15%, then I will call this relation to be elastic relationship, because a change in x is leading to a more than proportionate change in y. On the other hand, if I say, for example, x is changing by 10%, let's say going up by 10%, but y is going up by, for example, by less than 10%, for example, let's say 8%, we will call that relatively inelastic relationship, because the response of y to a change in x is less than how x changed, right? And then comes, for example, what if x is changing by, for example, 10% and y is also changing by, for example, going up by 10%. In this case, we call it a unitary elastic relationship. So what is elasticity? Elasticity is the responsiveness of some economic variable when another economic variable changes. So that's the important concept to understand, because when I look at demand now, let's look at demand, we know the two economic variables we want to look at is price and quantity, right? That's what we said. And we also said this: when the price goes up, quantity demanded goes down. So we know this, that the relationship between price and quantity is negative. But what we so far do not know is whenever the price goes up and quantity goes down, by how much, this is what is important to know, by how much will the quantity change. So for example, if I'm a business person, if I'm an entrepreneur and I'm selling my good and I'm thinking, hey, can I increase my price by 20%? And the answer is yes, you can, but that will make your quantity to go down by, for example, some percentage. So for us to know that percentage, or for him to know that percentage, is important. So for example, if the price goes up by 20% and the quantity goes down by 30%, then this business might not be thinking of increasing the price, because the quantity is going up down by much more. It is kind of a very elastic relationship, because the quantity is responding by much more. So we need to see through elasticity of demand how, when there is a change in price, the quantity demanded will go down, but by how much, right? So let's look at now that we know the framework, let's look at how the calculation of PED is done. We say price elasticity of demand is the percentage change in quantity demanded over percentage change in price. In other words, it is telling us the responsiveness. Let's also write down the formal definition: responsiveness of quantity demanded to a change in price. So when you look at PED, it is telling us how much will your quantity demanded change to a change in price. One thing we know for sure is that whenever the price goes up, the quantity demanded will go down. So there is an inverse relationship between price and quantity demanded. So we know one thing for sure: if this thing is going up, if the new denominator is going up, the numerator will go down, which means the PED will always be negative. Why is it negative? Well, we know this. If I look at the demand curve, our demand curve is downward sloping, right? So when the demand curve is downward sloping, we know this, that the relationship between these two variables is always negative. If the price goes up, quantity goes down. If the price goes down, quantity goes up. So when the price goes down, the quantity is always going to, for example, go up from P0 to P1. The quantity will go up from Q0 to Q1. So one thing is for sure, that the relationship is always negative. So that's why PED is always negative. But we don't know is when the price goes down, by how much will the quantity go up? And that's where the relationship is calculated through the formula of price elasticity of demand. I want to do an example for us to understand things better. So let's say we have a good, let's say chocolate, right? And let's say the price of a chocolate right now is $10. And the firm is thinking, the company is thinking that should they increase the price or not. So let's say price goes up from $10 to $12, they figure out the quantity will be changing as well. So initially they were selling 1,000 units of it, but with the price going up from $10 to $12, the quantity is now going down to, for example, 900 units. So when the price is $10, the quantity is 1,000. When the price is $12, the quantity is going down to 900. Now, let's figure out what is the price elasticity demand for this firm. So when you look at the percentage change in quantity demanded, the formula for percentage change, of course, is new minus old over old time 100, just to get the revision sorted. So I'm going to find out my PED, which is percentage change in quantity demanded over percentage change in price. So that will be 900 minus 1000 over 1000 divided by 12 minus 10, which is my new price. 12 is my new price, minus 10 is my old price, over 10 is, which is my old number, times 100. So both of these will be multiplied by 100, which is the percentage change formula. I can also get rid of these because, you know, they are both in the numerator and denominator. So if you look at the calculations, so 900 minus 1000 is minus 100 over 1000 divided by 2 over 10. So if I get all the zeros out of the way, I'm looking at minus 1 over 10, and this is 1 over 5, just to get all the math sorted, divided by 1 over 5, which is multiplied by 5, and the answer will be minus 5 over 10, or minus 0.5. Now, what does that 0.5 mean is something which we want to talk about. So I want to make kind of a range of PED to make you guys understand. We know the negative value is because of the inverse relationship, but what about the significance of the value? We know the sign is telling us the inverse relationship, but let's look at the significance of value also. So when you look at PED, the PED of any good ranges from 0 to infinity, and since PED is always negative, so we will ignore the minus sign. So PED is always negative, and because of this we can ignore the minus sign. So while I'm writing 0 and 1 and infinity to define this spectrum, we know this, the values, all of these values are negative because PED is always negative. So when you look at a 0 value, we have a 0 value which is called a perfectly inelastic demand. On the other hand, when you have a 1 value of PED, we call it unitary elastic, and I'll explain all of these in a little while. Unitary elastic. While if you look at infinity, that's what we call a perfectly elastic demand. So what we are claiming here is this, that elasticity of demand ranges from 0 to infinity. Now what about the values in between? The value in between, for example, 0 and 1 is between unitary elastic and perfectly inelastic, and we call this relatively inelastic. So a value of elasticity that lies between 0 and 1 is called relatively inelastic. On the other hand, if you have a value which is between 1 and infinity, for example, a 1.5 or a 2.5 or a 3.5, could be relatively elastic. So we have this range of values for elasticity. Remember, PED is always negative. So even if I say this is, for example, 0.5, I actually mean to say 0.5 negative or negative 0.5, or for example, if this is 1.5, where I actually mean to say negative 1.5. But for this discussion, we're ignoring the minus sign. So when the good is perfectly inelastic, the value is 0. And if it is between 0 and 1, it's relatively inelastic. And if it is between 1 and infinity, it's relatively elastic. And a perfectly elastic has a value of infinity, while unitary elastic means that the value is 1. Now let's see each of these values and also figure out their diagrams for our understanding. When we look at a perfectly inelastic demand curve is a little different from the demand curve we've been looking in the earlier chapter. We've always seen demand curve to be downward sloping, but when you have a perfectly inelastic demand curve, this is a unique good because it has what we call a perfectly vertical demand curve, which means that even though you might see the price to go up for this good, let's say price goes up by 10%, the quantity doesn't change at all. Now this is unique that in this case your demand curve is vertical at a certain quantity. So what kind of a good is such that whenever the price goes up for this good, we may still not be able to see the quantity to change that much? Well, we say a good which is very, very addictive, such as drugs, or any good which has no substitutes whatsoever, or a good that is life-saving is the one that may be in this category of perfectly inelastic good. In this case, percentage change in quantity demanded is 0. Does that make sense? Which would mean that for a good like life-saving drug, which you'll require for your life, you may not be cutting down on the quantity irrespective of whatever the price is. So you're willing to pay any price for this good and you're not changing quantity because your life depends on that. And this explains why your PED is 0, because if you look at the formula, it's percentage change in quantity demanded over percentage change in price. So if your numerator is 0 because the quantity isn't changing irrespective of whatever the price is, your value of PED will be 0. But one thing we need to remember is that for a good to be perfectly inelastic, our key assumption is that there is no substitute for this good. So if there is no substitute for the good, you may not have any option available to switch when the price goes up, right? And for this to have a no substitute, you need to have an extreme example like a hardcore drug, for example, which is very addictive, or a life-saving drug which is important for your survival, will come as an example for this kind of a good. One would say these kind of goods are relatively rare, but what is more likely to be seen is this case of relatively inelastic goods. So let's discuss relatively inelastic goods. When you look at relatively inelastic goods, these goods have a PED which lies between 0 and 1. So when you look at PED for these goods, I'm looking at PED that lies between 0 and 1. Now, when the PED is lying between 0 and 1, this means the quantity does respond to a change in price, but not that much. And I want to show you this through a diagram. If I look at this diagram, this is not perfectly vertical, but relatively vertical, relatively steep as we call it. The slope is steep, which would mean if I look at the price, let's say price goes up from P0 to P1 by 20%, the quantity isn't going down by that much. So if you look at this demand curve, by making it very steep, I've also ensured that the quantity is not changing by that much. For example, quantity is changing by 5%. Now, if I find out the PED of this good, right, using a formula, so you can see that my PED will be percentage change in quantity is 5% over percentage change in price is 20%. Minus 5% is the change in quantity because it's going down. So I'm looking at a minus 0.25 because 50 over 20 is 1 over 4, which is equal to minus 0.25. So ignoring the minus sign, I'm looking at PED that lies between 0 and 1. So when you have a good which is relatively inelastic, what does that mean? It means that the percentage change in quantity demanded is less than percentage change in price. So in other words, quantity is not that responsive to a change in price. Now, what kind of a good will be having such kind of a PED? And the answer to this is that one which has lower number of substitute. If a good has a lower number of substitute, for example, oil that we use for our vehicles and for energy is a good which has a very inelastic demand because there are few substitutes available right now, so it is a major source of energy for us. Similarly, medicine, general medicine also will have an inelastic demand, or for example, a medicine that is written by your doctor, prescription medicine, which is also going to be something which has a relatively inelastic demand because there are not many substitutes that are available. So one thing to remember for relatively inelastic good is that the demand curve is not perfectly vertical but very steep, making the percentage change in quantity demanded to be less than percentage change in price. Now let's move on to another unique case, which is unitary elastic. In a unitary elastic demand curve, our demand curve is such that percentage change in quantity demanded is exactly equal to percentage change in price. In other words, our PED is equal to 1 because the percentage change in quantity demanded is exactly equal to percentage change in price, which means that if I look at a demand curve, if the price goes down, for example, by 10%, the quantity demanded will also goes up by 10%. Remember that PED is negative, right? So this value is still -1, but we're ignoring the minus sign. So for example, if the price goes down from P0 to P1, by 10%, there is an equal and opposite change in quantity demanded that will take place. So quantity demanded will go up by 10%. Or for example, if the price goes down by 15%, the quantity demanded will go up by 15%. So that's why in this kind of a case, you have a demand curve where the percentage change in quantity demanded is equal to percentage change in price. Now, if you look closely, the shape of this demand curve isn't linear. It is a shape that is what we call rectangular hyperbola. And this is a shape that has a feature where if I go from, let's say, P0 to P1 and there's a 10% change, the quantity will be increasing by an equal and opposite amount. And therefore, the rectangle that is formed here, that's why the name rectangular hyperbola, this rectangle that I've formed here, which is basically P0 times Q0, this rectangle that is formed, that is exactly equal to this rectangle P1 times Q1. So in other words, this rectangle, if I can shade this rectangle's area is completely equal to the rectangle P0 times Q0, which is this one, right? And so that's why this has a particular feature. This graph has a particular feature that the demand curve has an elasticity demand which is equal to 1 throughout the length of the demand curve. Now if you move on, so if you look at the cases, we are done with perfectly inelastic demand where we saw there were no substitute whatsoever. Then relatively inelastic goods had a value which is less than 1, where we saw that percentage change in quantity demanded was less than percentage change in price, which means that the response is still low. But here we saw when it came to unitary elastic, the response was equal. So when the price goes down, the quantity will go up in an equal manner, which is where the unitary elastic comes into play. Now we'll move on to what we call the elastic range, which begins from PED greater than 1. So let's look at the case of a relatively elastic good, which has a PED between 1 and infinity. Now, what kind of a good will have such kind of a demand? Well, first of all, the percentage change in quantity demanded is greater than percentage change in price. So that's the first thing that we need to understand, which means the response is greater, and that's why the value of PED is exceeding 1, because the numerator is more than the denominator. That's number one. Now, this kind of a good is such that if the price goes up, for example, you have substitutes available for you to switch. So if the price goes up by, for example, 5%, and let's say you're thinking of buying a car, you might decide to switch to another car. You have more options available, and that's why you might see the demand to be elastic. So goods which have more substitutes available, will have such kind of a demand which is elastic. I want to show that first in a graph to make you guys understand. Again, we will now move on to show that here the response of quantity demanded is much more to a change in price. So for that to show, I'm going to make a very flatter kind of a curve, not a steep curve, but a flat kind of a curve. Okay, like something like that. Now if I look at this now, guys, look at this. If the price goes up by, for example, 10%, the quantity is changing by much more. Look at the gap of the change in quantity. The quantity is going down. In this case, quantity is going down by much more, for example, minus 20%. So a rise of price is leading to a change in quantity by much more, which means PED is equal to minus 20% over plus 10% or minus 2. So when you have a good which has a elastic demand, we argue this, that the percentage change in quantity demand is much more, which means that consumers might have more options to switch if the price goes up. Such a good, we will see also in a later discussion, has more substitutes available or is probably expensive. That's why people will switch and so on. The last case that I would like to do is the case of what we call a good that has a PED equal to infinity. So when you have a good which has a perfectly elastic demand, such a good which has a perfectly elastic demand, which is PED is equal to infinity, is a unique kind of a good because it has a demand where we say that a small change in price can lead to an infinitely large change in quantity demanded. Like people may have a very extreme response to a change in quantity demanded, and that could be a factor which results in a producer to not change the price. Now, what kind of a good is that, and what kind of a demand curve? Let's see this. So I am drawing a perfectly horizontal line for the demand curve, and I want to explain this. Let's say price is $10. Okay, so this is what I'm saying. This is my demand curve. Now, why is the demand curve for a perfectly elastic good completely horizontal? Well, the logic behind this is that this is a kind of good which has what we call a perfect substitute available. So there is a completely identical sort of substitute that's available, and as a result of that, if you change the price by more than $10, nobody's going to buy a good. Why? Because people will completely switch to the next best completely identical alternative that is out there. But if you lower the price, guys, you can also lower the price, right? Because if you lower the price, sometimes your sales can go up. And the answer is that in this case, you may not want to do so, right? Why? Because you will realize if I lower the price, my sales is not going to change. At that price, you might see people are willing to buy any quantity possible, but if you increase the price, you might see that the quantity demanded will significantly fall and you might lose all your sales because people will switch. In this case, if you look at the formula of PED, percentage change in quantity demanded over percentage change in price, if you can look at the equation, the percentage change in price is actually going to be 0 because you may not want to change the price, and that would basically mean my formula will have, let me write percentage change in quantity demanded. So anything divided by 0 will lead to a value of infinity. But in theory, what it means is this, that you might see an infinitely large kind of a reaction from consumers if you change the price. They may completely switch because such a good has a perfect substitute available, which makes people switch very easily if the price is any different than the market going price. A good example of this could be, like in the vegetable market, if you go in a bazaar or a large sort of place where many sellers of vegetables are present, everyone will be selling at the same price the vegetables, because let's say there's a potato seller, the potato seller will have an identical price to another potato seller because they are in a market where they're selling a perfectly identical good. So they can't have a price any different than the market going price. In the next video, we'll talk about how elasticity is determined for goods, and or what are the factors that make a good elastic or inelastic. And we'll also look at the relationship between price and quantity demanded when the demand curve is downward sloping. So we've looked at cases, but I would like to talk about how when the price goes down, the quantity demanded goes up for a downward sloping demand curve which is linear. And lastly, we would like to talk about an important thing, which is revenue and elasticity, how elasticity can determine a firm's revenue.